Welcome to Module 5 of Multi-Agent Architect. You picked a pattern in Module 4. You drew the diagram. You can articulate why that shape fits your problem better than the other three. That's a real accomplishment, and it's exactly half the job. The other half is design, the discipline that makes the pattern survive contact with reality. Real users, real workloads, real edge cases. The places where the diagram looks pristine but the actual run breaks for reasons the diagram couldn't show. In this module, we cover the 5 disciplines that separate a working prototype from a system you can put in front of users. State passing, how data moves between agents without bloating contexts. Context isolation, protecting the main agent's working memory. Verification, catching failures at handoffs before they cascade. The 5 canonical failure modes, what actually goes wrong in production. And recovery, designing systems that survive transient failures without manual intervention. By the end of this hour, you'll be able to take your Module 4 diagram and harden it into a real system spec. The kind another engineer could read, critique, and build. That's the bar. Let's start. Quick check. Card 1. You shipped Module 4. A 1-page architecture diagram. Pattern, agents, contracts, failure plan. If that's not done, loop back. The disciplines in this module attach to a specific design, and you need a specific design to attach them to. Card 2. You can feel the gap between diagram and system. The diagram looks right. You also know that the moment a real user hits this thing, something will break in a way the diagram doesn't show. That instinct is correct, and this module is the answer. Card 3. You're ready for production discipline. Up till now, we've been teaching shape what to build. This module teaches discipline, what to harden. They're different skills. Discipline is what you reach for when shape isn't enough. If you have a diagram in hand and want it to survive Monday morning, you're in the right room. If discipline still feels abstract, this module will make it concrete in 5 clear chunks. 3 deliverables. 1. Spec the contracts. Every handoff between agents in your system gets an explicit, enforceable contract. State, context, verification, 3 columns of discipline. Not vague intent, literal schemas, literal constraints, literal validation rules. 2. Anticipate the failures. There are 5 canonical failure modes in multi-agent systems, and they're remarkably consistent across teams. We'll name each one and pair it with one prevention pattern. By the end, you'll be able to look at a design and predict where it'll fail before it fails. 3. Build the recovery. Item map of the territory. 5 disciplines. Discipline 1. State passing. How data moves between agents. 3 options, prompts, files, tool returns, with different trade-offs. Production systems use all 3. The discipline is choosing per handoff, not per system. Discipline 2. Context isolation. Protecting the main agent's working memory from the inevitable bloat that comes from subagents reading large amounts of material. Without this discipline, long-running systems silently drift into incoherence. Discipline 3. Verification. Catching failures at agent handoffs before they cascade. Schema validation. Sanity checks. Sometimes a dedicated verifier agent in its own role. Discipline 4. The 5 failure modes. Context bloat, role drift, cascading hallucination, agent loops, silent partial success. Naming them is half the work, because once you can name them, you can prevent them. Discipline 5. Recovery and retry. Idempotency, checkpointing, transient versus permanent triage, human-in-the-loop fallback. The shape that turns a fragile pipeline into a robust one. 5 disciplines. 1 lesson each. Each one earns its keep when production hits. Part 1. State passing. How data actually moves between agents. 3 options at a glance. Read by columns. Option 1. Prompts. Persistence is ephemeral. Once the call returns, the state is gone. Size limit is your context window. Best for small contracts and fast pipelines where the data fits comfortably inline. Option 2. Files. Persistence is permanent on disk, survives across calls, across stages, even across sessions if you keep them. Size is practically unbounded. Best for big artifacts and multi-stage state, diffs, logs, anything that would blow up a prompt. Option 3. Tool returns. Persistence is ephemeral, but the structure is the win. Size is small and shaped, JSON-style returns. Best for parsable handoffs where the parent agent reads the structured object directly. Most production systems use all three. The discipline is choosing per handoff, not per system. Specs go in prompts because they're small and the next agent reads them inline. Diffs go in files because they're big and the next agent reads from a path. Verdicts come back as tool returns because the parent needs to act on them in code. 3 options. 3 tools in your toolkit. Pick the right one each time, and your system handles real artifacts at real sizes without choking. State in prompts. The cheapest option, the right default for small data. The pattern is simple. The orchestrator embeds the spec or the input directly into the next agent's prompt. JSON stringified, indented, formatted. The next agent reads it as part of its system prompt or user message.
No EQ, no parsing overhead, no scratch file.
What you get. Cheapest possible handoff. No extra work happens between the agents. Fastest possible handoff. No disk read, no network call, no parsing. Everything in the assistant's normal token flow. What you give up. Persistence. Once that prompt is consumed and the call state in files. The right tool when the artifact is bigger than a comfortable prompt embed. The pattern. Stage 1 writes the artifact to a known path. Stage 2 reads from that path. Both stages need to agree on the convention. Where does state live? What's it named? When is it cleaned up? We'll cover the scratch directory convention in 2 slides. What you get. Persistence. The artifact survives the call, survives the stage, even survives the session if you want it to. Practically unbounded size. Disk is cheap, and the next agent only reads what it needs. Multi-stage durability. If the system crashes mid-pipeline, the artifacts are still there. What you give up. Speed. Every read is an I/O operation. Coordination overhead. Both stages need to know the path convention. Cleanup discipline. Without explicit cleanup logic, your scratch directory grows forever. Where it works.
Diffs. Logs.
Big code outputs. Multi-thousand-line analysis reports. Anything that would dwarf the prompt budget if you tried to inline it. Treat the file system like a message bus between stages. Stage A writes. Stage B reads. If you're disciplined about paths and cleanup, files scale farther than prompts ever can. State in tool returns. The cleanest handoff for output the parent needs to read directly. The pattern. The subagent returns a structured object, verdict plus issues plus summary, or whatever your contract says. The parent reads the object as a normal tool return. No parsing of free-form prose. No scratch file dance. The shape is the contract, and the contract is enforced at the schema level. What you get. Schema-shaped data the parent can act on in code. Comfortable size. The structured return fits in main context without bloating it. No extra LLM call to interpret what the subagent meant. Testable handoffs. The scratch directory convention. The discipline that makes file-based state actually work. 1 folder per run. Put it at .scratch in the working directory. Numbered prefixes on every file. 001 for stage 1's output, 002 for stage 2, and so on. The numbers show stage order at a glance, even 6 months later when you've forgotten what the system did. A README at the top says what each file is in 1 line. Cleared between runs. Persisted within a run. The cleanup happens at the end of a successful run, after everything that needed the artifacts has consumed them. If a run fails mid-pipeline, the scratch directory stays. That's how you debug what happened. Why the convention matters. It lets every agent in your system know exactly where to read and where to write without renegotiating paths. It makes pipelines resumable from any stage. It makes debugging 10 times easier because you can just open .scratch and see what each agent produced. Adopt the convention. It's worth the small upfront discipline because it pays back 100 times over the life of the system. The alternative, every agent inventing its own path scheme, is chaos at scale. State versioning. The pattern for when agents iterate on the same artifact. Append. Don't overwrite. diff1, diff2, diff3, separate files, ascending numbers. Each version carries a short note in its file name or a sidecar, what changed and why. The agent that needs the latest version sorts the file names and grabs the highest. Why this matters. On rollback, you can reach for the previous version and the data is still there. You didn't lose it to an overwrite. On debugging, you can step through the iteration history and see exactly how the artifact evolved. On audit, you have a complete trail. When to prune. At the end of the run.
Part 2.
Context isolation. The discipline that keeps long-running systems from drifting. Context bloat. The silent killer of long-running multi-agent systems. Why it's silent. Every tool call adds tokens to context. Every subagent transcript dumped into the parent adds thousands. Long sessions accumulate slowly, then suddenly. Once your context approaches the model's limit, reasoning quality drops in subtle ways, the agent becomes less coherent, drifts off topic, forgets earlier decisions, contradicts itself. The pattern is invisible until reasoning collapses, and by the time it collapses, the run is already broken. There's no warning. There's no "you have 1,000 tokens left" indicator that triggers the pattern that prevents bloat. Subagents as context sinks. How it works. The main agent has a task that requires reading something heavy, a long log, a large codebase, a big document. Instead of reading it itself and bloating its own context, the main agent dispatches a subagent to do the reading. The subagent absorbs all that context inside its own session, reads the whole thing, reasons about it. The main agent never sees the source material directly. When the subagent is done, it returns a small summary, the answer to the question, not the source material that produced the answer. The main agent's context stays clean. It got the answer it needed without paying the token cost of the source material. The subagent's context, which absorbed everything, is now gone. It ended when the subagent returned, taking all that bloat with it. The arrow on the slide is intentional. It goes both ways with very different sizes. Big arrow out, tiny arrow back. That asymmetry is the whole pattern. Heavy reading goes out. Light summary comes back. This is why the role of explorer or researcher is so common in multi-agent systems. Those roles exist specifically to absorb context that the main agent shouldn't have to carry. The summary contract. The discipline that makes context sync agents actually work. Every subagent that exists to absorb context returns the same shape. Finding, the answer, 280 characters max evidence, references like file:"line, not pasted content. Confidence, high, medium, or low. Metadata for the parent's routing decisions. Optional next step, 100 characters max, suggesting where to look or what to do next. Hard size cap on every text field. The cap is the contract. Without caps, subagents will leak everything they read into their summaries. They're trained to be helpful, and dumping the source material feels helpful. The cap forces them to actually summarize. Evidence as references, not pasted content. If the subagent finds the bug at line 47 of authcontroller.ts, the summary returns the file path and line number, not the code at that line. The parent can read the code if it needs to. Usually it doesn't. Confidence as metadata. The parent uses confidence to decide what to do next. High confidence on a verdict means proceed. Low confidence might mean dispatch a second subagent for a confirmation pass. Confidence isn't decoration, it's a routing signal. Test the contract. Feed of worktree isolation. The file system analog of context isolation. When a subagent mutates files, it should do it in a separate working copy of the repo. A Git worktree. Same repo, separate working directory. The main agent's actual working directory stays untouched until the subagent's work is verified. How it works in practice. Main agent creates a worktree at worktrees/builder001. Builder subagent does its mutating work inside that worktree, runs the diff, writes the files, makes the changes. Verifier subagent reads the worktree, runs tests, returns a verdict. The anti-pattern. Dumping raw subagent transcripts into the parent agent's context. It's tempting because it's convenient. The subagent ran for a while. It produced reasoning, it produced output, it called tools. Just hand all of that back to the parent. Surely more is better, right? Don't. Raw transcripts contain reasoning steps, false starts, dead ends. The agent tried something, decided that was wrong, tried something else, eventually found the answer. Only the answer matters downstream. The reasoning is noise that drains parent context for zero downstream value. If you need debug visibility into what the subagent did, log the transcript separately to a file. You can read it later when something goes wrong, but it doesn't pollute the live conversation. Logs are for debugging. The parent's context is for reasoning. Different concerns, different storage. If you need the subagent to return more data than your current contract allows, expand the contract. Don't bypass it. Add a debug field. Add an evidence array. Whatever you need, but make it part of the schema, not a backdoor. Discipline holds. Convenience breaks. Pick discipline every time, especially when the temptation is highest. If you find yourself reading a subagent's full transcript at runtime, you've broken isolation. Audit the system. Tighten the contract. Don't let it happen twice. Part 3. Verification and handoff. The places where you catch failures before they cascade. Trust but verify. The principle that gets the discipline started. The framing matters. Every agent return is a hypothesis. The agent did its job, probably correctly.
Probably.
But probably correct isn't the same as known correct, and downstream agents need known correct inputs. Verification is what turns the hypothesis into a fact. 3 rules embedded in the principle.
1.
Don't trust agent output downstream until something has checked it. Trust the agent's effort. Verify its output. The two aren't the same.
2.
The cost of verification is small. A schema check, a test run, a sanity scan, these are cheap. The cost of cascading bad output through 3 more agents and surfacing the failure to a user is large. The math always favors verification. 3. Verification is cheap insurance, not bureaucracy. It's not friction added for its own sake. It's the only thing reality has against compounding error in a probabilistic system. The principle goes on every handoff. Schema validation between every agent. Sanity checks where the work touches reality. Verifier agents in dedicated roles when the work is high stakes enough to warrant them. Trust the agent. Verify its output. The discipline is small. The catastrophes it prevents are large. Schema validation. The first line of defense at every agent handoff. The pattern is simple. After every agent return, validate the shape against the declared contract. If the shape matches, proceed. If it doesn't, halt. Throw an explicit contract violation error. Surface to the orchestrator and to logging. Don't try to recover. Don't coerce a wrong shape into the right shape. Don't paper over a missing field. A schema mismatch is a sign that something deeper is wrong, and the cheapest possible action is to surface it loudly so you can fix the root cause. Silent recovery is how you ship subtly broken systems for months. The implementation is also simple. Define your schema once. Use a validator, JSON schema, SOD, whatever fits your stack. Wrap every agent call in a validate then proceed pattern. The overhead is negligible. The protection is real. If the shape doesn't match the contract, the run is already broken. Continuing is just adding more broken state to the broken state. Halting is what gives you a chance to fix it. Sanity checks. Beyond schema validation, run the actual work. After a builder agent, compile the diff. Run the test suite. Lint the changed files. Don't just read the diff and trust it's correct. Execute it. Builders hallucinate sometimes. Tests don't. After a researcher agent, spot check the citations. The agent may have invented a source that doesn't exist or attributed a quote to the wrong paper. Pull a random claim and verify it against the cited source. If the claim doesn't match, the whole research output is suspect. After a refactor agent, run the existing test suite. The refactor was supposed to preserve behavior. If any test broke, behavior wasn't preserved. The test suite is the contract. After a generator agent, eyeball the output. For text, check format and length. For code, check it parses. For structured data, check the structure. The eyeball is cheap. The failure to do it is expensive. Reading isn't checking. Reading the agent's output is just a heavier version of trusting it. Running the output is what tells you whether reality agrees with the agent. The pattern across all 4 examples is the same: touch reality somehow, in a deterministic way that doesn't depend on another LLM. That's verification. Verifier agents as a dedicated handoff layer. The pattern that scales schema validation and sanity checks into something modular. Trace the flow. Builder writes a diff. Instead of the reviewer immediately looking at it, a verifier sits between them. The verifier reads the diff in the worktree, not in the main context. Runs schema checks. Runs the test suite. Lints the changes. Returns a verdict object. If the verdict is approve, the chain continues. Reviewer runs on the verified diff. If the verdict is reject, the chain halts before the reviewer ever sees the broken work. Builder gets the failure feedback. The orchestrator decides whether to retry the builder or escalate. What you get. The reviewer never wastes time on broken builds. The builder gets fast, deterministic feedback. The orchestrator has explicit halt logic instead of cascading fallout. What you pay. 1 extra agent in the pipeline. The verifier's tokens. A small amount of latency. In practice, the verifier earns its keep the first time the builder fails, and that happens often enough in real systems to matter. The pattern adds 1 agent and saves many cascading failures. If the work is high stakes, production code changes, billing logic, customer-facing output, a dedicated verifier is almost always worth it. If the work is low stakes, schema validation and sanity checks inlined may be enough. Failure routing. When a handoff fails, the orchestrator has 3 responses. Retry. The failure looks transient: a flaky test, a rate limit hit, a network blip. Run the same agent again. Same input once. If it succeeds, move on. If it fails again on retry, escalate. The cost of 1 retry is tiny. The cost of escalating every transient failure is high friction. Reroute. The failure looks structural. The agent picked the wrong approach for the work. Hand the task to a different specialist or a different model tier. The original agent isn't the right tool for this specific request. Don't keep trying the wrong tool harder. Escalate. The failure looks fundamental. The spec is wrong. The work is intractable. Repeated retries failed. Halt the pipeline and surface. Live build. 8 lines of pseudocode that wire a verifier between builder and reviewer. Builder runs against the spec. Produces a diff. Verifier runs against the spec and the diff. Returns a verification object that includes whether tests pass and whether lint passes. If both checks pass, run the reviewer on the spec and the diff. The reviewer never sees broken work. If either check fails, retry the builder once with a failure as feedback in its prompt. Still failing after retry? Escalate to a human. That's it. 8 lines of orchestration logic. 1 extra agent, the verifier. That costs a fraction of what the builder costs. The chain becomes resilient against builder failures cascading into the reviewer. The reviewer's time is no longer wasted on tests that were going to fail anyway. The pattern is small. The pattern is also easy to skip when you're prototyping, because in the happy path the verifier is just overhead. Don't skip it. The first time the builder produces a subtly broken diff and the verifier catches it before the reviewer sees it, you'll know it was worth it. The verifier sits between builder and reviewer like a fuse, invisible when everything works, essential when anything goes wrong. Part 4. The 5 failure modes. The breakage patterns you'll see again and again in production multi-agent systems. Failure Mode 1. Context bloat. We named it as a concept in Part 2. Here it gets named as a failure mode you must prevent. What it looks like. Subagents leak their context into the parent. Reasoning quality silently drops. Long sessions become incoherent. The main agent forgets earlier decisions, drifts off topic, sometimes contradicts what it said 5 minutes ago. The user notices that a system that worked great early in the session is producing nonsense by the end. What it isn't. A model failure. The model is fine. The issue is that the model's context window is being used inefficiently, too much source material, too little reasoning room. Switching to a bigger model doesn't fix it. That just delays the same failure. Prevention. Summary contracts on every subagent return. Hard size caps on the summary fields. Never dump raw transcripts back to the parent. The discipline from Part 2 becomes the prevention here. The thing that makes this failure dangerous is its silence. Nothing breaks. Tool calls succeed. Returns are well-formed. The system just produces worse and worse output as the session drags on. By the time you notice, you've already spent the user's trust. This is the silent killer. Build the prevention in from day 1. Failure Mode 2. Role drift. Specialists do generalist work over time. Boundaries erode silently. What it looks like. Your reviewer agent, supposed to evaluate code without modifying it, starts suggesting fixes. Your researcher agent, supposed to gather information, starts editing files based on what it found. Your formatter agent starts making refactors that change behavior. Roles blur. Why it happens. Models default to helpful. Helpful means doing more, not less. When the reviewer sees an obvious bug, helpful is to fix it. When the researcher finds a typo while reading, helpful is to fix it. The agent is being good in its way. The system is degrading because boundaries are eroding. Prevention. 2 layers. First, hard constraints in the system prompt. Don't edit. Don't fix. Don't suggest fixes. Explicit prohibition language, capital must and must never, named negative space. Second, tool whitelisting. The reviewer doesn't get the edit tool. The researcher doesn't get the write tool. Even if the agent forgets the prompt rule, the tool list won't allow the action. Both layers together. Belt and suspenders. The prompt says don't. The tools won't. Either layer alone is insufficient. Prompts decay over long sessions, and tools without prompts produce subtle workarounds. Both, always. Failure Mode 3. Cascading hallucination. One agent's bad output becomes another's input. Fiction compounds. What it looks like. The researcher invents a citation, a paper that doesn't exist. The builder uses the cite to justify a design decision. The reviewer approves the build because the design looks reasonable on paper. Reality never enters the loop. The pipeline ships a fictional foundation, and the user inherits it. The danger. Each agent acts in good faith. The researcher believes the citation it produced. The builder trusts the researcher. The reviewer trusts the builder's code, which references the cite. The system has every step working correctly relative to the previous step, and the whole thing is wrong. Prevention. Verification gates between every handoff. Sanity checks that touch reality. After the researcher returns a citation, verify it against an actual database of papers. After the builder writes a diff that uses an external API, run a smoke test against the API to confirm it behaves the way the diff assumes. After the reviewer approves a security claim, dispatch a verifier that runs a fuzzer or a known attack vector. Verification is the only thing reality has against compounding fiction. Without it, hallucinations propagate and reinforce themselves until the user catches the lie. By then, you've burned trust. Failure Mode 4. Agent loops. Refinement loops that never converge. Compute drains. Nothing ships. What it looks like. The generator-critic loop runs 5 iterations. Then 10. Quality plateaus around iteration 4. The critic keeps demanding tweaks the generator can't make. The cost balloons. The user stares at a progress bar that just keeps spinning. Why it happens? 2 flavors. Either the critic is too strict, there's no quality bar high enough to satisfy it, so it keeps demanding revisions. Or the generator and critic are stuck in a back and forth where the generator's natural style fights the critic's preferences, and they never agree. Both manifest the same way. Forever. Prevention. 3 safeguards from Module 4 here mandatory. Max iteration cap, 5 by default, hard limit. Cost ceiling, halt when token spend exceeds the budget you set. Quality plateau detection. If 3 consecutive iterations score within 5% of each other, you've converged in practice. Stop. Why are all 3? Belt, suspenders, second pair of suspenders. The downside of having all 3 is 1 wasted run when 1 stop condition triggers a halt you didn't quite need. The downside of having none is unbounded compute, often. Failure Mode 5. Silent partial success. Some agents fail. The system doesn't notice. The user sees done. This is the most insidious of the 5. What it looks like. You dispatch 5 agents in parallel. 3 return successfully. 2 fail. 1 timed out. 1 returned a malformed object. The orchestrator's aggregation logic concatenates the 3 successful returns and produces a final result. The user sees a complete-looking answer. The 2 missing pieces are gone, silently. Why it's insidious. There's no error message. The system reports success. The user has no signal that anything went wrong. They might rely on the answer for hours or days before noticing the gap, and even then, they may not realize the gap exists. Prevention. 2 parts. First, explicit per-agent failure decisions in the orchestrator's code. Don't have a generic skip failed agents fallback. Each agent's failure has an explicit handler: degrade, retry, abort. Second, aggregation that surfaces gaps loudly rather than hiding them. If 2 of 5 agents failed, the output should make that visible, annotated, called out, impossible to miss. The output should always make missing pieces visible, not paper over them. A user who sees a partial answer with the gap labeled can decide whether to act. A user who sees a complete-looking answer with hidden gaps acts on bad information. This failure mode is worth specific defensive code. Build it in. 5 failure modes, 5 preventions in 1 table. Context bloat, summary contracts with hard caps. Role drift, hard constraints plus tool whitelist. Cascading hallucination, verification gates, and sanity checks. Agent loops, iteration cap, cost ceiling, plateau detection. Silent partial success, explicit failure handling, and visible gaps. The pattern across all 5. Naming the failure mode is half the work, because once you can name it, you can prevent it. Each prevention is a specific, implementable discipline, not a vague principle, not a be careful note. Code you write, contracts you enforce, schemas you validate. Wire all 5 preventions into your design before you ship. Then audit quarterly to make sure they haven't drifted. The audit takes 10 minutes. The catastrophe one of these would cause is hours or days of debugging plus user trust burned. A reasonable shipping criterion. If you can name the prevention for each of the 5 and point to the line of code or the schema that enforces it, you're ready to ship. If you can't, your design has gaps the failures will find. This slide is the one to print and tape next to your monitor. 5 failures. 5 preventions. The taxonomy of why multi-agent systems break. Last section.
Part 5.
Recovery and retry. Designing systems that survive transient failures gracefully. Idempotency, the first foundation of recovery. An idempotent agent produces the same outcome whether it runs once or 3 times. Same input, same output, same side effects, or in the limit, no additional side effects on subsequent runs. Why this matters? In production, you'll retry agents. Sometimes the orchestrator retries because of a transient failure. Sometimes the user retries because they're not sure whether the first run actually completed. Sometimes a recovery script retries because a previous run crashed before reporting status. If the agent isn't idempotent, retries cause damage. How to design for it? Avoid uncomputed mutating side effects. If the agent appends to a log, dedupe by run ID and stage name, same identifier means the entry already exists. Don't add another. If the agent writes a file, write to a version path, so a retry doesn't clobber the previous run's output. If the agent calls an external API, use idempotency keys when the API supports them. Test it. Run the same input twice. Verify the result is identical. If it's not, find the mutating side effect that doesn't dedupe and fix it. Retry safety isn't optional in production. Build it in from day one. Retrofitting idempotency into a system that wasn't designed for it is one of the harder refactors you'll do.
Checkpointing.
Save state at each pipeline stage so you can resume from anywhere. The pattern. Each stage of the pipeline writes a checkpoint to the scratch directory. Stage 1, plan. Write spec to stage 1 spec.json. Stage 2, build. Writes the diff to stage 2 diff.patch. And so on through verify and ship. A status.json file at the top. Failure tria. Distinguishing transient from permanent failures. Transient failures are retriable. Network timeouts. Rate limits. Flaky tests on a known flaky path. Provider 5xx responses or service blips. Resource contention errors that resolve on their own. The shared property. The failure is about temporary external conditions, not about the work itself. Retry the same input. It'll likely succeed.
Permanent failure ni d'escalation.
Authentication or permission failures. Your credentials don't work. Retrying with the same credentials won't help. Schema validation failures. The agent produced wrong. Human-in-the-loop fallbacks. The pattern that makes a multi-agent system production-ready. After n failed retries, surface the situation to a human. Don't loop forever. Don't escalate silently. Give the human a clear surface, what was attempted, what failed, the latest checkpoint state, and the choices available. What to show them? The full pipeline state, summarized. Which stages succeeded, which failed, what each one returned. Links to the scratch directory artifacts so they can dig deeper if needed. 3 or 4 explicit options. Resume from the last good checkpoint. Override a verdict. Rewrite the spec. Abandon the run. Quick recap. By the end of this hour, you can do 5 things. Pick state passing per handoff, prompts, files, or tool returns, based on what fits the data. Isolate context with summary contracts and worktrees so long sessions don't drift. Verify every agent return, schema first, sanity second, dedicated verifier when warranted. Anticipate the 5 failure modes and prevent each with a named pattern. Design for retry, checkpoint, and human-in-the-loop fallback so your system survives transient problems. The assignment. A spec plus a working prototype of a 3-agent system. The spec includes explicit state contracts at every handoff, not vague intent, literal schemas. A failure plan plus verification gates per agent. Idempotency, checkpointing, and a HITL fallback as first-class design choices. The prototype runs end-to-end and demonstrates each discipline. Diagrams that don't run aren't designs. The discipline of making it run is what makes the design real. Ship the prototype. The shipping is the lesson. You'll discover what your spec missed only by trying to make it work. 3 concrete actions on 3 time horizons.
Today.
Audit your Module 4 diagram against the 5 disciplines: state, context, verification, failure modes, recovery. Mark every gap, every place where your diagram doesn't have an answer. 30 minutes. The audit alone will reveal what your design is missing. This week, write the system spec: state, context, verification, failure plan, recovery, explicit per agent. Use the Slide 31 summary as your checklist. The spec is the contract between you and your future self. This month, build the prototype. 3 agents. All 5 disciplines wired and demonstrable. End-to-end run with at least 1 HITL pause to prove the human pathway works. The prototype is the assignment, and the assignment is the system. The system you ship is the lesson. You can read every slide in this module, take perfect notes, and miss the point, because the point is what happens when the disciplines actually meet a running system. Module 6 next, packaging and shipping as a plugin. The Harden prototype from Module 5 becomes the product in Module 6. See you there. Common gotchas. 5 traps you'll hit when hardening a Module 4 diagram into a Module 5 system.
1.
Summary contract too strict. Subagents lose information that mattered downstream. The summary capped at 280 characters became 320 in practice, and the cap clipped the part that the next agent actually needed. Loosen the cap, or expand the schema with a structured field for what was missing.
2.
Worktry never merged back. The user runs the system, gets a shipped verdict, but their actual repo has no diff. Somewhere in your merge logic, the worktree got abandoned without a final merge. Test the happy path end-to-end before. Up next, Module 6. Packaging and shipping your system as a plugin. Where Module 5 hardened the design, Module 6 wraps it for distribution. 4 topics. Plugin.json, the manifest in detail. Required fields, Semver discipline, repository links, component declarations. The metadata that decides whether your plugin loads cleanly on someone else's machine. Bundling primitives. Agents, skills, hooks, commands organized so they all load together. Naming conventions. Cross-primitive references. Documentation that drives adoption. Clean environment testing. Why works on my machine kills plugin adoption.